to my channel. Today we're going to work on the question medium of two sorted arrays. It's a hard level question, and the question states, given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be O log of m plus n. Let's look at example 1. Nums1 equals 1 and 3, nums2 equals 2. So the combined of nums1 and nums2 would be 1, 2, 3. And since the length of this is odd, we just take the middle number for the median, which is 2. Looking at example 2, nums1 equals 1 and 2, nums2 equals 3 and 4. The combined array would be 1, 2, 3, 4. It's a length of even number because there's 4 numbers here. In this case, we take the middle two numbers, which is 2 and 3, and average them, which is 2 plus 3 divided by 2 equals 2.5. So what's hard about this question is it's asking an overall runtime complexity of O log of m plus n, not like normally O of n plus n, because if it's like a brute force solution, solving this question directly would just be O m plus n. So I'll go through the brute force solution of this question quickly before I go through the optimal solution. So basically brute force, we can combine 1 and 2 into a sorted list. nums1 and nums2. And then we find the middle number, which is 1, to find the median, which is length of nums, or division by 2. And then we check if the list is odd or even. So if length of nums modulus 2, there's no remainder. If it's an even number, then we return the average of the middle two, right? So it's nums mid plus nums mid minus 1. It's mid minus 1 because in this case 4 floor 2 equals 2, and then index 2 is 1, 0, 1, 2, which is 3. And then we have to add 2, which is index 1, right? So it would be mid minus 1 and divided by 2. And in the else case that it's odd, then we just need to return the middle number like this. So we just return nums mid. So this is the brute force solution. However, this doesn't fulfill this question's time complexity. This time complexity would be O of m plus n. And this space is also like additional space, O of n plus n. Okay, so even though the solution is accepted and it works, it doesn't fulfill this question's time complexity. So we're going to try to solve this question using a better time complexity, using a modified binary search approach. So imagine nums1 equals x1, x2, x3, x4, x5, x6, and then nums2 equals y1, y2, y3, y4, y5, y6, y7, y8. So let's say we put our partition here, like in binary search. If you know binary search, it has like partitions and there's left and right sides. So let's say we put our nums1 partition here between 2 and 3. So this is the left side, this is the right side. That means we have to put the partition for our nums2 here because we have to make sure both sides are equal. Or equal halves, not just equal among themselves, but equal combined together. So here we have 2, and here we have 5. 2 plus 5 equals 7, right? And here we have 4, 4, and here we have 3. So 4 plus 3 also equals 7. So both the left side combined in nums1 and nums2 equals 7, and the right side in nums1 and nums2 also equals 7. So basically, after we partition nums1 and nums2 into a correct partition, we also have to check that every element on the left side is smaller than or equal to every element on the right side. So partition here, we know for sure x2 is smaller than x3 because it's sorted, but is x2 also smaller than y6? This is what we have to check. So we have to make sure that x2 is smaller or equal to y6. And also we have to make sure y5 is smaller than or equal to x3. And after we've made sure our partition is in the correct place, and we have equal elements in the combined left side and combined right side, then in the case that if it's an even number, even combined list, then we need to find the average of the match between x2 and y5. And the average of the min of x3 and y6. And else if it's an odd case, so we need to just find the match of x2 and y5. So basically this is the algorithm, and I'm going to try to write this in code. By the way, we have to make sure that nums1 is smaller than nums2, just because the algorithm performs, or we want to perform binary search on the smaller list because it saves time complexity, or else we want our total time complexity to be O of log of min between m and n. M and n is like the length of nums1 and nums2. It might be clearer if I say nums1 and length of nums2. So to get the min of this, we have to perform the binary search on nums1, which is always going to be less than nums2. And to make sure of this, we can have it as if statement in the beginning to check for this. If length of nums1 is greater than length of nums2, then we have to switch them. We'll do in place swapping. Nums1, nums2 equal to nums2, nums1. And then let's define some parameters and variables that we're going to use. Length1 equals length of nums1, and then length2 equals length of nums2. Also, we have low and high when we're doing binary search, so our low, and by the way, this low and high is only used for nums1 because we're performing binary search on nums1. Low equals 0, and then high would equal the length of nums1, which is nums1. And all low smaller equal to high. We calculate our partition 1 equal to low plus high for division 2. Partition 2 equal length 1 plus length 2, so the total length plus 1 for division by 2, and then we minus partition 1. We minus this so that the left side is always like equal. The combination is always equal to each other. So we're going to write some edge cases to check. We don't want our partitions to go out of bound of nums1 or nums2, so we'll do if partition 1 is equal to 0, then there's nothing on the left side, right? So max left 1 equals float negative infinity. And else max left 1 equals nums1 partition 1 minus 1. We do minus 1 because we're working with 0 index. We start on index 0, so we have to minus 1 from it. And then we check if partition 1 is at its max length 1, then min rate 1 equals float positive infinity, else min rate 1 would equal nums1 partition 1. And if partition 2 is equal to 0, then max left 2 equals float negative infinity, else max left 2 equals nums2 partition 2 minus 1. Also because of index we need to minus 1. Start at index 0. And if partition 2 equals its max length 2, then min rate 2 equals float positive infinity, else min rate 2 equal to nums2, and then partition 2. So this is all of our edge cases, and in the case that we found the correct partition, which means that if max left 1 is smaller or equal to min rate 2 and max left 2 is smaller than equal to min rate 1, this is basically saying this y2 is smaller than y6 and y5 is smaller than x3. And that means we found the correct partition. And we check if it's odd or even. If, let's say 1 plus 1 2 modulus 2, so the total length divided by 2, if there's no remainder, then it means it's even. Then we return the match between the middle two. I mean the average between the middle two numbers. But we have to pick the max of max left 1 and max left 2 plus the minimum between the min rate 1 and min rate 2. And then we divide it by 2. Else, if it's an odd number, then we just return the max between max left 1 and max left 2. And in the other case, if our partition haven't been solved correctly yet, we need to move our pointers within nums1. So if max left 1 is greater than min right 2, then it means our left is too big. We need to move our left point, our pointer, to the left. So high would just equal partition 1 minus 1. And then else, we need to move our pointer the other way. Low equals partition 1 plus nums1. So this is the final code, and let's try to submit it. The time complexity for this would be O of log min of n and n. So basically it would be O of log min of nums1. I mean O of log nums1. And space would be O of 1 because we're not using any additional space. Thank you so much for watching, and let me know if you have any questions.